All right, I want to end chapter 12 just kind of summarizing some discussion of kinetics and kind of the purpose or the utility of what we're talking about. So when we care about reaction rates, really insofar as we want to control them, we want to speed up reactions and make them faster. Any reaction that we're doing or that we want to occur, if it happens faster, it will be better. And we have kind of some guidance as to how we can do that. At a base level, you can always increase the concentration of reactants. That will always work to increase the rate of your reaction. But not always available because say you're already at a highest concentration possible. You may have a liquid, you may have pure substances. You can't make them more concentrated. You can increase pressures of gases, but you can only do so much. If you got a solid, you got a solid. Well, you can always heat up the reaction. That will always work. Hotter always leads to faster, but that can be very expensive and it's not always safe, right? And you don't want to just be lighting fires under everything. Another problem with that is it heats up every single chemical reaction. So say you have one chemical reaction that you want to occur, you may drive some alternative reactions. It may end up being more wasteful because the reactants that you have just start doing other random chemical changes, things start changing in unpredictable ways, and that's not what you want. You want to have only speed up your one reaction, but it still will work to heat up a reaction. If you have, say, solid reactants, you could change the shape of them. You could turn it into a powder. You can dissolve it. That is always going to work and has a high utility and is frequently used, but has limited applicability. So the gold standard of what we want to do is use a catalyst. Make an alternate mechanism that has a lower activation energy. This is the gold standard of how we drive chemistry, selectively increasing the rates of reaction that we want to do. It's also really difficult to do, but it lets you control exactly what reaction happens. So at a reasonable temperature, right? You can say you generally do run things at elevated temperatures because it's easier to control warm than it is to control room temperature. And this is how industrial chemistry occurs. So any sort of pharmaceutical creation, oil and gas refining, creating plastics, modifying plastics, you're using catalysts to do those because you want to speed up the rate of one particular reaction. It's also how all biological reactions occur. Enzymes are biological catalysts. This is how your body governs what chemical reactions occur. Living things want to have chemical reactions occur on demand, but they also living things want to have regulation of what's going on. If you just heated up the living thing, all chemistry would happen, right? You want to have enzymes that have control over very specific chemical reactions. You have enzymes for every single elementary step that could potentially happen. And that's a lot of control over things. Now, like degradation and breaking things down like stomach acid, anything goes. But any sort of building or building molecules or small changes, it's all enzymes regulating and catalyzing elementary steps. So in terms of how we look at kinetics experimentally, you determine the rate law, getting the overall order, you can figure out your Ks using your initial rate method. If experimentally you want to know the kinetics of a reaction, you start by doing initial rate method, you figure out the order of your different reactants, you can get some information on the rate constant. From that, you would figure out the rate constant at different temperatures. You use the Arrhenius equation, and that lets you determine, say, the activation energy. And once you know the activation energy, that lets you make more quantitative predictions as to how you can speed a reaction up using temperature. It also can kind of give you some insight as to what sort of a realistic reaction mechanism would be. You can kind of get some guidance as to how high the barrier is for what's going on there. That also lets you hypothesize a reaction mechanism in terms of matching up the orders of your rate law. That's really how we kind of verify a reaction mechanism. And once you know a reaction mechanism, you can come up with a catalyst to make that reaction go faster. What is your rate limiting step? And how can you fix that? How can you change how that works? Can you put in acids? Can you put in bases? Those are really common catalysts that and sort of things like that. Is the heating up the temperature just the way to go? What is the kind of control that you want to get? And that's kind of the idea of what we want to be able to do when we're talking about controlling kinetics and understanding what makes a reaction, how reactions actually happen, and therefore how we can control the rate at which they happen.
That's chapter 12. There's a lot here. It is a long chapter. It's three full sets of videos, the longest we've had so far, going back to just defining kinetics, computing rates, all integrated rate laws, collision theory, mechanisms, all these kind of different parts as to how reactions actually happen. Very, very rich area for chemistry. There's a lot here.
And that is going to do it. 3 questions on participation 918. You want to find all 3 of those, get those answers, get the questions answered, and get the answers submitted over on Blackboard by Friday night. There will be answers that go live at that time. That is it for this week. That's it for chapter 12 material. No other videos. We got the homework due Saturday, post lab due Sunday. If you have any questions about anything, let me know next week. There's no Tuesday participation. There's no first set of videos. We'll just have the exam on Wednesday. If you have any questions about anything, if you want to meet in person or online to talk about the material on the test, let me know, or come to office hours. Otherwise, enjoy your weekend. Check out those answers on Friday night for the participation. Take it easy. Bye.